To go.
All right, folks, welcome. I'm Mike D'Antonio. I'm otherwise known as Dr. Mike, and I am your host for this session. I'm going to be the host of many of the Become an Amateur Weather Forecaster series. And if you haven't had a chance, go ahead and check out the recording. It will come up soon for the kickoff that we did yesterday. Today we have Blair Brightwriter. Did I get that right, Blair? Yes, good. Okay. And she's with the National Weather Service in Albuquerque, New Mexico. And she's going to take us through the life of a weather balloon. And so I'm going to go ahead and turn it right over to you, Blair, and you can take it away.
All right. Hi, everyone. Like you said, my name is Blair Brightwriter. I am a meteorologist with the National Weather Service in Albuquerque, New Mexico. In case you're unfamiliar, the Albuquerque Weather Service office is located right up by the airport. So as I kind of walk around, you'll see that we got all sorts of planes back behind me. So at some point, I'm outside. If it starts to get a little loud, I'll be sure to try to go inside so you can hear me. But if you lose me at any point, just let me know. Flag mic down, wave your arms about. We'll get the hint. So like you said, we're going through a day in the life of a National Weather Service weather balloon. Now, something I bet you didn't know is that this is a global effort. It happens twice a day. Once here at, I bet you can't guess. If we're doing one now, and we do them twice a day, there's 24 hours a day divided by 2, so we would do them 12 and 12, right? So 0Z, which is when everybody sends theirs up, or actually 23Z, when we send them up all around the globe, here in New Mexico, and during daylight standard time, that happens at 5. Not so bad, right? 5 p.m.? But what's 12 hours prior to 5 p.m.? 5 a.m. So we have a meteorologist or a hydrometeorological technician that comes on scene here, and they either get here in the afternoon or they get here at 4 o'clock in the morning or 3 o'clock in the morning if it's Mountain Standard Time, because we lose an hour, right? But like I said, they go up twice a day. One goes up here, he'll go up here at 5 p.m. for a 6 p.m. reading, and then one at 5 a.m. for a 6 a.m. reading. And what this is, I'm going to try to turn my camera around. See if I do it. All right. So you can see our upper air building out that way. And what we have basically is exactly what you think. It's a balloon, right? And it'll expand and get real big. This one's actually really small. It's one of the ones that we use for our fire weather deployments. So you see, it's real tiny. And here in a little bit, my coworker Troy is going to come out and he's going to go blow up our regular one out in that thing. So I guess my question to you guys, and you might not be able to answer it, but is how big do you think this little balloon that I just showed you, you can see my hand next to it, how big do you think that balloon's going to get? So it could be 4 feet, it could be 8 feet, could be 10 feet, could be 2 feet. So if you have access to your chat room, try and type a number in there and we'll see what you guys come up with. Here is Troy now. He is going to go walk out there and take the balloon out and show them how little it is, how tiny. There it is. It's itty bitty, you guys. It's really small. So he's going to take that out to that upper air shelter. We'll follow him out here in a minute. But first I want to talk to you about how this all works. We blow up that balloon. We tie a whole bunch of string.
If you have an answer to your question.
Oh, what is it?
Okay, we got 2 answers actually.
All right.
3 yards and 10 feet.
And 10 feet, is that the one I saw?
3 yards and then one 10 feet.
Awesome. Okay. I'm not going to give it away yet. I'm going to wait until you guys see that balloon blown up, and it's going to blow your mind. All right. So we take that balloon, we take this guy, and we're going to basically just use a whole bunch of string. Actually, we're going to use 100 feet of string, which is a ton of string. And we're going to tie it to the end of this little thing. This guy is basically an itty bitty little computer. He's called a radiosonde. And that just means that he radios information back to us from the very different various levels of the atmosphere. And so if you look here, we have one sensor here. This guy takes temperature. It does so by measuring the resistance in the air. And usually there's like another little section right here. You'll see it on the sonde that we actually are sending up. This one's really old, but it measures temperature. And if we turn it about, let's see, here it is. Also measures humidity. And then on top of that, it measures wind, and it does so by GPS. So it talks to a bunch of satellites, it gets its idea of where the balloon is, and it does a whole bunch of math to tell you how fast those winds are and what direction they're coming from. So it's really, really cool. And how that works is that balloon, today, Troy will launch it from that building, and it's gonna go take a trip all the way to the Sandias and beyond. A weather balloon on average can get anywhere from 100 kilometers away to 250 kilometers away in its given life. And that flight will last anywhere from an hour to an hour and a half. So it's kind of crazy. That balloon, we've picked them up all the way on the other side of the border of New Mexico, which is really quite incredible. So we're gonna walk all the way over here to the upper air building. And at this time, Troy is unpacking that balloon. You would think that we would use helium for this, right? Because we all go to the Chuck E. Cheese and all those places that give you balloons. They all use helium. But we actually use hydrogen, which is a little bit intense. And as we walk up, you'll see some of the danger signs. Hydrogen is incredibly, incredibly flammable. So we have to be very, very careful. It means that I cannot go inside the upper air shelter with my phone and with my neat little stabilizer here because it could spark. And so here it is. You'll see kind of the difference between my itty bitty little fire weather balloon and this one. This one you'll see kind of lays out across the whole table here. And it's only just getting started. But you'll see that it's got this nozzle. It runs all the way around out to here where we have these hydrogen tanks. And they're gonna fill it up. And the reason we use hydrogen is, for one, it's cheaper. And for two, it gives us a much more stable lifting rate. We want it to be as consistent as possible to get the best reading that we can for every level of the atmosphere. And so Troy is going to tie this parachute in, which is mandatory, required, so that when that sonde, eventually that balloon's gonna pop, right? It's gonna fall out of the sky. This way it gets in a nice, comfortable landing and it doesn't hurt anybody or land on a car. So he's gonna tie that in. And while he does that, we're gonna do some contemplation here. So I said it goes all the way over the Sandias, right? So with that in mind, the Sandias are, we'll just generalize 10,000 feet up above where we are right now. So it's gonna go over that. So we know it gets higher than 10,000 feet, right? But the question is, how high do you think it's gonna get before that balloon pops? So before I let you answer that question, I'm gonna give you some food for thought. We're also looking at this airplane right here. What height do airplanes fly at generally? Generally, they want to fly above the weather, and that's usually above 30,000 feet. So this weather balloon is going to maybe go near or above 30,000 feet. So in the chat room, I want you guys to put in an idea of when you think, I'm going to try to get out of the wind so you can hear me. Put in the chat room when you guys think that this balloon is going to actually pop.
While we're waiting for their answers, can you mute just a second?
Yep.
Yeah, while we're waiting for their answers, I'm going to give you a question that came up, and then I'll mute and you can answer it. And as, how does the balloon talk to the satellite? And by the way, you two girls, you should put your answers in the chat room. How high do you think this balloon's going to go before it pops? I'll be watching for your answers there.
Okay, so that's a really great question, and we'll get into some more of the specifics of it after the launch. But I'm going to back up, and hopefully the wind doesn't get too bad. If it does, somebody chime in and let me know. But I want you to be able to see this big dome up here. So this whole thing, underneath that dome, has a giant dish that is going to basically radio back information. Basically every second we're going to get temperature, we're going to get relative humidity, we're going to get wind, we're going to get its height. We're going to get that every second via a radio transmitter that is within that little computer that I showed you guys, the Radioson. And then this that we're looking at right now, this what we call a TRS system, it is going to talk to that system over there, just barely on top of the National Weather Service building, and that will let it talk to our computer, and that's how we're able to analyze and QC that data that comes in. And by QC, of course, I mean quality check and make sure there's nothing strange going on. And so, yeah, it doesn't even really get to talk to satellites. It's a pretty much self-contained system that radios that information straight to us. There's nothing in between. The only satellites that it's going to talk to is for its GPS. All right, I see some answers in there.
So we got 25,000 feet, maybe 29,000. And I can give a guess too, but I'll probably be cheating because I've actually launched one of these, so I won't say anything.
That is fantastic. I love it. Okay, so 25,000 feet about there, yeah? Okay, get ready for this. This is going to blow your mind. Let me turn my camera around because you guys are basically just looking at airplanes. Okay, so planes fly at 30,000, right? This balloon will likely pop at about 100,000 feet. That's almost a space, right? How crazy is that? So this guy, well, let me turn this camera around. There he is. He's still got a ways to go. And I would say, what do you say, Troy? That's maybe 5 feet so far? Yeah, he's got a ways to go. Now,
that balloon looks bigger than that.
It's going to get so big that it's almost hard to get out of this door.
Oh my God.
I know, it's crazy. So here's something really cool also to think about. So you guys probably haven't learned about this in science yet. It's a pretty advanced concept. But, let me turn this back around. So there's a thing called the natural gas law. And for the sake of variables and math and how that stuff works, it's PV equals nRT. That doesn't make much sense. That doesn't really mean anything. But what it does suggest is that pressure and volume equal mass, and then also R, we won't get into R is complicated, and then T, okay? So as we go up into the atmosphere, and we're going up to what? How high was it? 100,000 feet?
100,000 feet.
100,000 feet. So as we go up in the atmosphere, if you've flown before, you know that they always talk about something called cabin pressure. And cabin pressure basically is saying that the air is too thin up where you guys at 30,000 feet in order for you to breathe. And so as we go up, pressure comes down. So what is pressure? We hear pressure a lot, but a lot of people don't necessarily think of what pressure actually is. Pressure is basically force. So if I were to push on my nose, it's pressure. I'm putting pressure on my nose. It is force applied over an area. Now, as I go up in the atmosphere, that pressure is less and less and less. So what do you think happens to a balloon as pressure decreases? If there's less air forcing pressure onto it and keeping it at what's now maybe 6 feet, what do you think is going to happen to that balloon? Put some answers in the chat.
Yeah, let's let them talk. If you can mute your microphone, we'll let them actually say it this time. Go ahead and tell her what you think the answer is.
I think that it won't pop very soon because less and less pressure is pushing it together.
Very good. What about the other young lady that's with us? Yeah, she doesn't want to talk.
I was gonna say, Layla, do you have anything?
I don't think she knows how to
So
mute herself.
something you guys should know, I actually launched several of these weather balloons, just like the ones they're doing here, only mine were helium. And they also went up to 100,000 feet. And I actually, one day after I launched it, I watched it. And I could actually see it all the way to about 29,000, or I'm sorry, to about 90,000 feet, just before it popped. I could actually still see the balloon. I got really good eyes. So surprised the folks, but I actually pointed it out and we checked the GPS and I was correct. So
Wow.
So go ahead, Blair, you can take it from here.
All right. So you're right. It's not going to pop very quickly, right? Because we're putting less pressure on it and on it. The gas that's in that balloon is going to kind of expand as we move up into the atmosphere because less pressure is being put on that casing, we'll say. By the way, look at how big it got. Because you can see Troy, right? It's as big as Troy. It's bigger than Troy. Troy could sit in that balloon. It's crazy.
That'd be cute.
So, so that balloon, as it rises up, because there's less force on it, the force is going to let it expand and expand. So that balloon is going to get bigger and bigger and bigger and bigger until it reaches a quite absurd size. So,
and then it will pop.
And then it will pop. But what size do you think it's going to get to before it pops? Right before it pops. When we're at 100,000 feet, how big is that balloon where it only has 6 millibars of pressure? For comparison's sake, we're at about 800 right now.
Maybe 80 yards?
Yards. What about you, Layla?
I think, I don't know. It's a hard one. I know. It's a big balloon. Looking.
It's already big already, right? But 80 yards is actually, I think, closer than I've seen before. But it actually gets to be about the size of a school bus or a small house. 30 to 45 feet. So if we turn the camera around and we're looking at the National Weather Service building, perhaps about a good portion of that wall here is how wide that balloon is going to get before it finally pops and falls back down. Now, do you think that's going to shrink back down as it falls once it's been expanded and it's huge and it's huge? No. So it's crazy when this thing actually does finally pop down. It's going to pop down and all of its, little extra innards are going to fall down with it, and it can be quite a scene. But we do try. We have a little packet on the radio sound, and we'll go look at that. He's going back inside now. But
I can't believe how small it used to be and how big it is now.
I know. So it's a really interesting type of material, right? It has to be really, really strong and really durable to be able to go from something that you can hold in the palm of your hand to something that's this big. And so if we were being pretty far from it, but I'll get right up next to it, and it's going to swallow the whole screen. It is massive. Now, can you imagine with a balloon that big, if you guys are in New Mexico, which you are, can you imagine? It's not bad today, right? The wind's not too bad. Can you imagine taking this out of this building when there's like 50-mile-an-hour winds?
It just blow away.
So it'll contort and it will actually look really strange, but it can withstand that, which is really quite incredible. Okay, what's that?
Does Jeff not it?
Yes, you do.
How hard is that?
It's not necessarily too hard. It just takes a little bit of muscle memory and practice. So everybody does it differently. But you can see Troy actually does it a lot differently than I do. He loops it around several times and then he does 6 knots in order to get it so that this doesn't leak. Some of us, Troy's been doing this for a really long time. When I do it, I end up flipping this up. So I make an extra little safety loop And then I'll tie another kind of round of knots there, kind of like I'm tying my shoe. And then that way I don't have to worry, just in case it's leaking. I don't trust it. I don't trust myself. So I try to put as much in between this deflating as I possibly can. The balloon can get to the size of the room it's in. Yes, definitely. So, let me see. Oh, it's not on this door. It was so small. I was trying to look.
Little balloon.
Now it's massive. So, for reference to Layla's typed in question, can the balloon get to be the size of the room? Actually, it's a really good reference for that. If you're looking back at this door here, its width here is 10 feet.
Actually, that was Maria said it.
Oh, okay. Okay, yeah. So this is about 10 to 12 feet. The balloon's about 8. And so it easily will be bigger than this area right here when it finally does decide to.
I just can't believe it.
I know, it's crazy, right? All right, so we're going to walk back this way.
What kind of material do they use?
I think it's a latex. It's a very, very, very sturdy latex. And the old ones used to, I think they were also like a latex as well, but they were like a real strange brown color, which was kind of neat. So if you look up old photos on Google later of weather balloons that were launched in like the 50s, 60s, and 70s, you'll notice they're like a really weird brownish yellow color, and it's kind of for those reasons. They actually were a little bit more durable and were a little bit heavier than these are. But the way that we've been able to make materials, the advancements in that, we've been able to make them lighter, and therefore they're a little bit more economical to make, a little bit easier on the environment.
Does the color sometimes affect the weight?
Not necessarily. Not necessarily. I think back then it might have had to do with the processing and how they made them, because things back then were so much different than they are now. So I think that has more to do with it than the actual weight of it or really anything else. It's just a different process.
What was the size? How big was it on the largest time?
How big was it? What, like the largest one that we've ever seen get popped?
Yeah.
That we don't know, because we can't monitor that necessarily. When it's up there and doing its business, we're not necessarily worried about this guy. We're worried about what the computer is sending back. So we can do these calculations just using physics and math. And so then you just have to visualize that, oh my goodness, it is this big. Now, that said, there are other agencies in New Mexico that are doing other types of atmospheric research. They're actually doing space weather research and the likes. And those balloons, when they go up, are already 30 feet wide. So it's kind of crazy, and those will go up pretty high. You can, like Mike was saying, he could see his before it popped when it got up to 20,000 feet. With these balloons that you see, these other sorts of research balloons, they're already massive, and you can see them as you're coming in on 40 and the like, on I-40. You can see them off in the distance, and a lot of times they're mistaken for UFOs, but they're not. They're just weather balloons. Mike asked a question. What weight is this balloon? This is a general purpose 600 gram. All right.
What's a gram?
A gram is just a unit of measure. It's kind of like a pound. You know how many pounds you are. It's just another way of talking about weight. Oh, here comes Sir Randall. I don't know what Sir Randall is doing, but we're gonna bother him. All right, we're gonna walk back to the building. He's running away from me. I think Randall knows that I'm going to come and ask him questions. It's one of our other meteorologists.
Go ahead and mute you girls for just a minute.
He's literally running.
He kind of is. I'm trying to run after him, but it's not working out. All right. So we're coming back to the building, right? And I told you this is where we're going to receive that information. Technically, we receive it from the building behind me, right? That stuff gets radioed in to the upper air shelter. That's what we call that. And then the upper air shelter sends it to us in the actual National Weather Service building. So we're going to walk over here. We're going to run in. And what Troy is doing, he's going to be basically doing what we call a baseline process. Let me check. Okay. And so here's a modern sound. So here's a modern radio sound. Here's that temperature sensor that I showed you guys outside. Here is the relative humidity sensor. And so now, you probably can't, I don't know if I can make it so you can see that. Nope. And so Troy's just dialing in where he thinks the winds are going to take the balloon, so he doesn't have to race back in here and try to fix that right as soon as he gets the balloon launched. All right. Yeah.
Where was the balloon when it popped the furthest away you've ever gone?
For me, I want to say probably probably over 150 kilometers. What about you, Troy? Do you have a memory of one that you launched that got super, super far away?
Yeah, I would say definitely at least 150.
At least 150, yeah.
Depends on the elevation.
Yep, it sure does.
For the folks at home, what would be 150 kilometers away from Albuquerque?
Ooh, that is a good question. What would you say is 150 kilometers away? Because I can't do miles in my brain. What is 150 kilometers to miles? I guess that's the question we have for us without our calculators as we walk. Or those of us who can't do math and walk. Or anything else and walk, which would be me.
Yeah, I just did a calculation. It's about 100 miles.
About 100 miles. Okay, so what, like Santa Rosa to Tucumcari-ish? Somewhere in between there, you think? So that's pretty far.
It was Christmas. Well, let me, in El Paso, when they launched, the furthest we ever got was about Las Cruces, when we did the launches, Cave to Bois. But 100 miles would be close to Socorro.
Oh, wow.
Dang, that's incredible. So a funny story with this guy. So here he is. The best story I have with this is I got a call from our Center Weather Service Unit, which is our kind of National Weather Service sister office that works with the FAA. And they asked, "Where is your balloon right now?" And I was like, "Well, it's about 20 kilometers to the east of us." And they said, "Oh, well, that's good to know because we just had a pilot radio in because he passed it." So that's pretty funny. All right. Here we go. So remember what I said about that 100-foot train? Woo! So he's trying to get it as far away from the building as he can because the building can suck it back in. All right, you guys ready? Here it goes. Whew. Whoa. Everybody say goodbye. I always say goodbye to mine and tell them to do good science. All right. So Troy's now gonna close this whole thing up as he just did. And he's gonna race back into the building and start watching the data, make sure it's coming in. And there's nothing erroneous about it. There's nothing strange or weird. The pressures aren't wrong. If something like that happens, or if the radiosonde itself has any sort of malfunction, well, then we have to start this process all over again. And part of that process, I think I saw a question in there, is how long does it take to fill that balloon up? It's about 7 to 15 minutes, depending on how well you're regulating the air that's going into it. But you don't want to blow it up too fast, because you don't want to stretch that material out too fast. You want to give it as nice and gentle of an inflation as you can so it lasts as long as it can. So we're going to walk back. With the balloon pop, if what?
If you blow it up too fast.
It's not going to help it, that's for sure. And if you really blew it up way too fast, it probably would pop, which would be no fun. That's a big balloon. Can you imagine how loud that would be?
Yeah.
I have luckily never had one pop, but it's one of my greatest fears. I tie the balloon on myself, please don't pop.
We popped one with helium.
Oh, that would be fun.
It wasn't a big loud pop. It just put a big hole in the balloon and kind of went.
All right, so we're gonna come over here and just do some cool discussion, just so you guys kind of get an idea of how far the science has advanced over the last, century, which is crazy to even think about. So we talked about the sonde. Let me turn the camera around again. We talked about the sonde, we talked about the balloon itself. And so what if I told you that we have been doing this as a science since 1749? Which is crazy, right? So were there radio transmitters? Was there GPS and whatnot back in 1749? No way! There was none of that. None of that. We'll actually walk over here and we'll look at some of these older instruments so you guys can kind of get an idea of what this means. So when this was going on back in the late 1700s, the early 1800s, this sort of measurement was taken by kite. That might ring a bell because you probably know of a guy who might have flown a kite to do some weather observations, right? Benjamin Franklin. Crazy man. Put a key up on a kite, discovered electricity and all that. Yeah, it's crazy to do, right? So around that time, so 1749, we get to the 1800s, they're starting to do manned descents. So they're basically doing like hot air balloons. They're going up with their instruments and just taking measurements as they go up. Now, I think you might, after we've talked about this, right, about pressure, how things change, how cold it gets up there, what do you think was a limiting factor in doing a manned descent? So people in a balloon trying to take these measurements. Might have been a little bit cold, right? Might have been a little bit cold. And on top of being really cold, the air thins out. Because remember we talked about cabin pressure. If you're in a plane, you get up to 30,000 feet. If you don't have that cabin pressure, if you don't have that plane kind of getting you back to what we would understand as kind of like a sea level pressure, it's going to make it really hard to breathe. The air is really, really thin. And so people actually lost their lives going up in these balloons and trying to take measurements. So those were going up until the 1800s. And the kites were used through the 1800s.
Wait, people were in the balloon?
People were in the balloon.
How did they get out?
They would get in little baskets, just like your balloon Fiesta. So they were in little baskets, just like you would see here at Balloon Fiesta. And they would go up just the way you see them go up for those. And they would take with them the thermometer and whatever relative humidity sensor they had. And then also a little barometer to measure pressure. At that time, they couldn't measure winds, not quite the way that we can now. In fact, winds didn't come along for a really long time. But you can see how this is not ideal. They're going up in balloons, it's frigidly cold, the air gets really thin, people actually died. So yeah, the Aeronauts. There's a movie called The Aeronauts, and that's exactly it. And that was brought up in this whole research of how they went up and they did pass away. So the kites were used through the 1800s. They did temperature, they did pressure, relative humidity, and they did it on a clockwork-driven chart recorder. The thing with all of that is they basically had to go track these instruments down. So like nowadays, we launch these balloons. When they pop, they fall down. If people recover the sondes, they can send them in and they can be repurposed. But we don't have to go find them, right? Because the whole time that this is going on, that building is getting the information and sending it to us. But back in the 1800s, again, there weren't radio transmitters. So instead, they sent up these old thermometers. You guys might have seen these. See if I can, whoa, never mind, we're not going in there. They're wasps. That's bad. We won't go look at the thermometer. Y'all know what they look like. They're full of mercury and they measure temperature and they're real big. So anyway, but the kites can't get very high either, right? So if we're doing this as a kite, you're limited as to how much string you can put up, and you have to sit there and man it the whole time. And it's still not radioing back information necessarily, right? So for the inability of the kites to be able to actually achieve high altitude, that actually fostered the development of radio transmitters. So we can thank weather balloons for the fact that we can actually listen to the radio in the car. I think that's pretty cool. And so then once we get to that point, that's like the 1930s and 1940s where this starts to happen. And at that point, we still don't have GPS, right? Can you guys imagine a world where you can't like just type in where you want to go and, you know, find it and drive there and it tells you to turn left on Carlisle? Like, that did not exist yet. And so what they had to do...
Awful.
That's awful, right? So I'll walk us inside real quick and I'll show you this really... It's a really old... Almost like a... So I'm going to walk you guys inside. I'm going to show you this old instrument called a theodolite. And what you basically had to do was watch the balloon, like kind of like how Mike says, he has good eyes. I could not have this job. I have terrible eyes. So they would watch for the balloon with this instrument because they had to go track it down, right? So let me go find it in here. We still have ours. Let me turn the camera around. There it is. So it's kind of like a telescope.
What is it again?
It's a theodolite.
I thought it was like a can of sort that you have.
Right? Isn't that cool? So
I
it's
know.
kind of like a telescope, right? And you can see it's got these little things to make sure things are level.
That'd be so weird.
Oh, yeah. I'll go back out here. How's it going? Doing good? We're having a good time right now. All right. So here you guys go. Here's kind of how this all works. Here's all this information coming in, right? It comes in about every second. There's the GPS that we were just talking about, right? Which we love. We love GPS. And then we have this. This is the telemetry, so we can kind of see where it's gone. And we just monitor that. We monitor that for the next hour and a half. All right. So yeah, the next hour and a half, it's gonna continue going on, and as it catches different levels of the atmosphere, it'll actually change in direction. We'll be able to track it. There are some sondes or radio sondes that are called wind sondes that you actually can track all the way until they die, and you can go pick them up, reuse them, which is great because this is obviously not that great for the environment as these things just become, you know, littering about. So, but yeah, that's about all I have for you guys. Do you guys have any questions?
Whenever the balloons pop, does the GPS thing get damaged?
No, the GPS, once it senses that the balloon has popped, the GPS actually just kind of, what we call terminating the flight. And so it just kind of ceases the transmission, and then the balloon and the computer fall back down with their parachute. And then they're either recovered or they're not, but in a lot of cases they are recovered and they're sent back in and reused.
We actually had one that would go high beyond the clear, and it would track all the way down.
Yeah, and we had those at my university, and they were called wind sondes. And then after we did a flight, we would actually go chase them down and get them and repurpose them. Yeah. All right, does anybody else have anything they want to ask or add, or?
So the balloon I saw actually reached 90,000 feet before I was able to see it.
Say that again, Mike.
It actually almost reached 30 kilometers, which is about 90,000 feet.
That's incredible.
Before I lost sight of it.
90,000. Geez, I thought you said 20,000 feet.
Oh,
That's
90.
amazing. Yeah, and I know in the wintertime, we talk about that in the office a lot, about how if it's really, really calm, we can sit out here and we can see it for quite a while. And if we break out that old little theodolite, then we can track it real far. Although back in the day, for that guy, they actually couldn't track them much more than 5 kilometers, which I find surprising, really. But that was just what they said in
This
their
was in the
research.
summer, and I actually did it with the naked eye.
See,
No
that's
telescope.
incredible. I can barely see this thing. Like, I couldn't find it now if I had a gun to my head. Like, I have no idea. I just don't have that good of eyesight.
And I never quit watching it, because the moment you move away, you lose it.
Yeah, you'll never find it again because it gets to be about the size of a pin drop.
Get to 30 kilometers per over an hour.
Yeah, I believe that.
For over an hour.
What time of year was that?
It would have been June or July.
Nice. Yeah, that's really, really incredible. Very impressive. Cool. Anybody else have any other questions?
Do you have any more questions, you two?
Whenever the balloon leaves and it's popping,
Has it ever landed on somebody's car in somebody's yard?
Yeah. Yeah, we've had.
Were they mad? Did they make you pay them?
They were not mad. I've heard. Now I have just heard stories. This has never happened to me, so this is all hearsay. I've heard a story of a balloon that popped, and the package, so the radiosonde and the balloon and its parachute, landed on a car. And the lady who was driving the car did not know what it was. She thought it was a bomb. And so she called the bomb squad, only to find out it's just a weather instrument. But yeah, I think it scares people because most people don't realize how big they are, how big they get. They don't know what they look like. They just know weather balloons are a thing. I've never actually seen one. So I think it can be a little scary when they actually do turn up.
So if you don't mind moving for a second, Blair?
Mm-hmm.
Okay. When we did this, we actually were looking for ozone, so it was a little different, but it was the same balloon, exactly the same balloons. We did the 300 that you did, but we did a couple 600. And yeah, they went all the way up and we tracked them all the way down. But what we did before we sent them off, we did several things, and something you should know. One, we just tried to predict where the balloon would land. And we were pretty good at that. We could actually make sure that it didn't land in an airport or on a highway or in a populated area. We tried to make sure it landed in an area where it wasn't populated because we could choose the times we launched. Just wait a minute and I'll let you ask questions. And then one of them actually landed within 100 feet of one of the local prisons. So we had to call the prison and let them know there's a balloon going to come down. It's nothing special. We did that. But we actually had to call the airport, right? And I think you do too. We had to call the FAA. We had to call, I think we actually called you guys up there in the National Weather Service and let you know we were launching the balloon as well. We had to make about 5 or 6 phone calls before we could launch. And then every about 10 minutes, we had to make several phone calls again so that people knew where it was. And so the local law enforcement knew where it was in case something did happen like that. All right, go ahead.
Get your foot out of my face.
The question is, whenever the balloon lands and pops, how big does it expand? Because I'm pretty sure there's usually like a hole in it. How long can it stretch out to be?
So ours will stretch out to be 30 to 45 feet. So like you saw here, and that's in diameter. So I mean, that's from one end to the other end. That's 30 to 45 feet. And then you have the entire circumference. That's even larger because that's a different measurement, right?
Yeah.
So 30 to 45 feet and that thing pops. And like I said, that material is not going to shrink back up just because you're increasing pressure as you come down. That mess of the latex or whatever materials that are being used, that whole giant mess is going to come with it. So it can be really kind of striking when you see these balloons that have come back down along with the orange parachute and the radiosonde, because it's huge.
Wow. That's neat.
The ones we launched also made noise. They would do a little buzzing sound like because of the ozone sound that we had in there. And that would actually last for like up to 5 or 6 hours after it landed. So you could walk up to one of these and the package was about this big. And you would see a styrofoam package and it would be buzzing. Bzzz. So in big letters, it says, "This is not a bomb." And then we told them what it was and how to return it if they found it.
This is not a bomb. Just for safety, so they don't think it's a bomb and then get everything messed up. Because if they say it's not a bomb, they'll know what it is. Because if you tell them what it is, they'll know where to return it and everything. So people aren't freaking out.
Quick question. Can we see the balloon right now?
It's
I've looked real hard. I don't see it up there. I'm imagining by now it's caught some westerlies up in the upper levels of the atmosphere, and it's trucked its way over to the Sandias, and it's probably long past them. So
Good eyes. I'm sure he could spot it.
he could, but he's actually not here.
Ah.
Yeah. So
I'm sitting in Las Cruces.
Yep. And so we have the same thing. We were talking about the whole bomb situation. We have the same thing here with us. This is our old Radioson, but you can see it says here that harmless weather instrument. It's, if it's not dangerous, please, send it back if you find it. So it's a thing. People they've not really seen them very much if they've never been exposed to one. It does look very, very strange out of context. So. And then we always write, the station location, the date that it was released on, the time it was released on. And so that's always kind of cool. Yeah.
We actually offered a reward if you returned ours, because ours were more expensive than what they send up, very much more expensive. And so we tried to track them down, and I would put the GPS in my car and drive to where we thought it landed when we could. Many times it landed in the mountains and we didn't want to drive up there. But if it landed in somebody's farm or something like that, we'd drive over there, knock on their door, ask permission to go out on their farm and go get it. And we got about 1 in 10 back. And we launched, I think, 67 weather balloons in one summer.
What's the prize if the person finds it and returns it?
I think the prize that we gave was like $20. So if you actually find one, and these were all launched in El Paso. So if you find one in the El Paso area and you see that it's offering a reward, my understanding is we can still pay out that reward. Please return it. We would like to have it back.
Why would you want to return it? It exploded.
It didn't, not the balloon. We don't take the balloon. We take show them the sonde.
The
we
GPS?
take the box. That's what we got. Our box is probably about 4 times bigger than that, and it's encased in styrofoam.
How does the box get there?
The box actually is attached to the balloon. Right now, it's actually the one she launched earlier is flying in the air right now. And then when the balloon pops, it comes down with the balloon. And in fact, the parachute is to protect the sonde more than the balloon itself. The balloon doesn't do a whole lot, but the sonde can actually come down pretty fast if we don't put a parachute on it.
Ow. Ow.
So you wouldn't want one of those to hit you on the head at full speed. So we actually slow it down, and by the time it reaches the ground, it's probably going like a few feet per I can try to remember. It was like on the order of 3 feet per second. So it was really slow.
Has it ever hit anybody on the head or touched anybody?
Not that I know of. Not that I know of. But even if it did, it's coming down very slowly. And so by the time it hit the ground, what we really worried about is we didn't put the parachute on correctly. It could sometimes come down without the parachute. And that always was worrisome. So we really tried hard to make sure it wasn't in the city that it would come down. It was always in the countryside or up in the mountains somewhere.
Did they break?
Is that why you chose El Paso? Because I mean, it's not very city or
No, actually, it's a
building.
bigger city. The biggest city is Albuquerque. And so we do worry about that. But we actually predicted where the balloon would land. And we got pretty good at that. I was actually the one that I had to wake up at like 2 a.m. and run the program and make those predictions, and then call my team. And we drove from Las Cruces to El Paso, and we would launch at a certain time. I would tell them exactly what time to launch, and they would launch within that 10-minute window. And if they couldn't do within the 10-minute window, we'd have to wait. I would have to do more calculations to make sure it didn't land in a bad area. All right, folks, we're coming up on 5:30. I think does this go till 5:30 or 6 o'clock? Do you remember?
I don't know.
Oh, I should
Just
have.
said it wouldn't realize.
I think we were set up to go until 6, but I don't think I have much more in regards to this particular topic, unless you do, Mike.
So if you guys want to ask more questions, we can ask more questions.
Any questions? Not that I know. It's pretty clear.
Well, I mean, how many buildings are there?
How many buildings, like how many National Weather Service offices?
In New Mexico.
Oh, in New Mexico, technically there are 2, but the El Paso office, they say they're in El Paso, they're in Santa Teresa, New Mexico. But as for serving the New Mexico as a state, Albuquerque actually takes care of all of the counties with the exception of the most southern row, and that's El Paso's and Midlands area. But we have the largest county warning area in the entire country.
And how many weather balloons are launched about a month?
So we do them twice a day. So that could be 60, could be 62. The other thing to consider is, so there are also offices when you think of like New Orleans or Tallahassee, any of those coastal offices, they have to consider, hurricanes and tropical developments. And so they'll actually do what's called specials. And those specials can be launched at any time, whenever needed. And they can even go as far out at, inland as Texas and into Oklahoma and Kansas, so that they can sample what is going on in the atmosphere near where these hurricanes are about to impact.
Richard reminded us that we should submit the feedback forms. You can see it up there on your screen, but also in the chat room. You put the link. So make sure you do that, and you'll be eligible for prizes.
A lot of money.
One of the prizes Richard will bring is a golden rain gauge.
And what do you know when you get the job? The weather balloon.
Okay, so, sorry, my stabilizer is dying. So you can there are two specific jobs that work with the weather balloon. One, you saw Troy. Troy is a hydrometeorological technician. And so he works primarily with acquiring data and kind of dealing with the public and doing upper air, which is what the weather balloon is formally called upper air. And then the other is meteorologists. And so for meteorologists, what you generally have to do is you go to college, you get your degree in atmospheric science or environmental science or just general science. The main requirements of it are that you have to have a good amount of physics, you have to have a decent amount of math, and we're talking some pretty upper level math for it. And then I'm trying to remember what else we specifically had to have. You have to have a certain amount of meteorology classes. So just kind of understanding how the atmosphere works and all the different scales of atmospheric development. And that's Usually that's a 4-year degree, so that's a bachelor's degree. A lot of people go in and they get their master's degree, which is 2 to 3 more years. Sometimes it's 5. And they'll either study atmospheric chemistry, or they might just continue in with atmospheric science. They might go into remote sensing, which is like satellites. There are a lot of different ways to get into this sort of field. For me personally, I have a degree in what's called Earth System Science with a concentration in atmospheric science. My background before this was I worked at NASA, and I helped to maintain what's called a lightning mapping array, which is a bunch of different computers spread out over a certain area that kind of keep track of what lightning is happening 24 hours a day, 365 days a year. And so we have to keep those computers up all the time.
So you did a lot of weather work.
I do a lot of weather work. So I'm now a meteorologist here, and I do forecasts, I do research, I launch the weather balloon, and I do outreach like this. And it's awesome. It's a really, really cool job. Other people with my degree go into broadcast meteorology. So those are the guys that you see on TV telling you, what to expect in your day and over the weekend. And we work really closely with them as well.
And just so you know, when I did the weather balloons as part of a research part, I actually had other people come and help us launch. So we actually offered to a youth group at a church in El Paso to come, and they came, and 2 or 3 of them, and they helped us launch the balloon. We would when we were at UTEP, we had some of the UTEP students helping us out. So researchers are a little bit freer to do that. You wouldn't be able to do that at the National Weather Service because you're a government office. But when researchers like myself and David Dubois, and if you check out our kickoff, you'll see us there, we actually can allow other people to come and be a part of it. And it's kind of fun. We don't do launches very often. We maybe every few years we'll get something where we have to launch some weather balloons. And if we have that happen, we'd let people know and ask if you want to join in. So it's kind of neat.
And we do something similar. Mike has a lot more freedom than we do. Like you said, we are a federal agency. So I can't bring you guys inside the upper air building. I can't let you touch the balloon. We have all these restrictions. But we do allow for field trips, at least when we're not dealing with what we're dealing with right now. We do have field trips that come in, and we give tours of the office. And if you schedule them at the right time, then you do have the option of coming and seeing this in person and actually getting to witness the weather balloon launch, and also talk to some of the meteorologists about their job and what they get to do in their day-to-day. So it is really, really cool.
What is the name of your job?
Which one, me or Mike?
You.
I'm a meteorologist.
What's Mike's?
They asked what yours was, Mike.
Oh, I'm sorry, I didn't hear. Yeah, so I'm actually a physics professor at New Mexico State University. I teach physics. So I teach people like Blair here the physics they need to know in order to be able to launch these weather balloons. And Dave Dubois, who I work alongside of, is actually an atmospheric scientist. And he's the climatologist for the entire state of New Mexico. So he handles all the weather instruments, he does all that work, and I actually work in his office. I do research alongside of him. So we do a lot of stuff together, and that's how I got involved in this, and that's how I became an amateur weather forecaster, which you can become one too if you follow some of the series and talk with people like Blair and I. You can learn enough, and you could actually predict some things about the weather. So I got pretty good at it, actually. And I've got lots of wonderful pictures that if you check out the recording for the kickoff, you're going to see all some of the pictures I took. And if you follow me on Zoom, and I'll give you that here, it's simple, at Antonio Mike. If you go there on Zoom and follow me, you'll see all the pictures I take for the National Weather Service because I'm one of their spotters. And I'm often spotting for them, and I'll be sending pictures. And sometimes I just put pretty pictures up too. And so last summer, by the way, I actually was I was visiting in Santa Fe, and Blair, I don't know if you were there at the time, but I actually did some spotting and actually saw a wall cloud come in and actually saw a funnel cloud and took a picture of that and sent it off to National Weather Service in Albuquerque. So if they look at their records, they will see my Twitter account, and in my in the kickoff, I actually talk about that. You can actually see what I sent to them.
What's a funnel cloud?
Funnel cloud is, okay, so a tornado, you know what a tornado is, right?
Yeah.
You've heard of those, right? A funnel cloud is a tornado that hasn't reached the ground yet.
We once had one of those in Missouri.
Pull my hair.
Yeah. And so that one actually occurred last summer up in Santa Fe. And I was visiting there and was lucky enough to see it coming. And I actually waited till it passed over, counted a few minutes, and then I went out and looked to see if I could see it. And yes, the funnel cloud was there. And if you want, I might be able to pull that up for you guys. Give me a moment to see if I can do that.
What are all the types of clouds that we know of? I know there's one, the cirrus, but I don't know the other types.
Barry, you want to take that one?
Yeah, that is a loaded question. So when you think about clouds, the easiest way to do it is to kind of think of them in three specific types. So cirrus is one, and I'm sure you know what that looks like. Those are like the feathery, really thin, really wispy. The other ones that you're probably very familiar with look like cotton balls, and those are cumulus clouds. And then the third type, you might see it. You see it more in winter than you do like in the summer, with the exception of like last week. Everybody remember what happened last week with that crazy storm we had? Those would have been stratus clouds. And so then from there, so you have cirrus, cumulus, stratus. From there, we start dividing those into other clouds. So you have cirrocumulus, you have cumulonimbus. You guys know what a cumulonimbus cloud is?
I think so. They're like those big puffy clouds.
They're the big puffy clouds, but specifically cumulonimbus is the rain clouds. So when those big puffy white clouds start turning gray, which means that they're starting to get more and more and more water in them to the point that they start to precipitate, right?
What cloud is that? Funnel cloud.
Oh, is that the funnel cloud? Awesome.
The funnel cloud, we thought it was gathered, it was coming down.
Ooh.
This is close to hide out.
That was a mega tornado funnel cloud because it was coming down out of the clouds. Very unusual.
It is, yeah. I was about to say it's very unusual to see up in Santa Fe. It's unusual to see in Albuquerque. They're more commonly seen kind of more in eastern New Mexico. And
We still live in Missouri longer than we still live here, but
yeah,
That's what I'm saying.
but we've never had tornadoes.
Yeah, our father seeing funnel clouds like us. That's pretty much all.
that's probably ideal. Yeah, tornadoes are scary.
Yeah.
They can do a lot of damage, but you know, luckily out here we don't see them very much. And when we do see them, since they're in eastern New Mexico, they're usually over rural areas. So we get lucky out here that we don't.
I saw this one. I went inside.
Yeah, you go inside. They can be incredibly dangerous.
With us, we had to hide out because we were on the highway.
That's awesome. So yeah, so when it comes to clouds, there are so many there. I'm sure you guys, you might have lived here long enough now that you've seen lenticular clouds.
Yeah.
Yeah, so those form specifically kind of over mountains and have to do with how stable air is versus how unstable air is below it, and they get that cool like disc pancake look to them. So that's another type of cloud. It almost seems endless when you start to think about how many different clouds there are. I think, is Mike showing us more? Oh, are you showing lenticular clouds? Yay, they're so pretty.
They're colorful.
That's a picture I took.
And they're colorful.
Do you usually get them during sunset?
Not necessarily. I've seen them in the morning when I'm working the morning shift for the balloon. I've seen them out over the
Sunrise and
sand.
sunset?
We can see them at sunset. It just depends on what the atmospheric conditions are. They have a very specific set of things that need to happen for them to form.
And I have another question.
What's that?
How can you? I read this book, and it said that whenever the moon has a bunch of,
when it's
when it's really bright,
danger
danger
means
means
there's
a
storms
storm
coming
coming
in.
in.
I just
I just
want
want
to
to
know
know
if
if it's
it's true
true
or
or
false.
false.
I
Because
think
I've read it,
I think
and
it's
I'm
not, it's not necessarily true. I wouldn't take it as saying yes, it's going to happen or no, it's not going to happen. A lot of what that is water vapor in the air. You can see it really, really well, and it kind of makes that whole ring sort of illusion to it. It'll make that in the presence of like very humid, very saturated air. And so generally, especially here, if we're seeing very humid, saturated air, we might see rain or storms the next day. If you see that in, say, Missouri or Alabama, that might just be an everyday thing. So it's not necessarily indicative of bad weather or rain or anything else. It just is saying that there is a lot of water vapor in the air.
I have another question.
Okay.
How does mist get formed?
Or
Say that
fog.
one again.
How does
How does
mist
mist
or
or
fog get
fog get
formed?
formed?
How does fog get formed?
Yeah.
Okay, so I like to think of fog as literally just having a cloud on the ground, because that's practically what it is. When I say the air is saturated, what I'm saying is that there's a lot of water molecules within the air where you're at that time. So kind of when we think of like how dew forms, you know, when you go out and you look at grass and you actually see the little dewdrops on it, that's kind of another way to think of fog. So fog kind of forms in the same process of like there's a lot of water vapor down at the ground, and it condensates because the air gets to a certain temperature, and it's the same way that clouds form too. It's just a little bit lower.
So if you look at the picture I just showed, it's actually a fog bank in Las Cruces. This is a picture I also took, and I'm going to question Blair. Blair, do you know what kind of cloud this is?
Oh, I have to see if I can. There we go. Oh, Calvin Helmholtz waves.
Yes, and it's now got a new name.
They look like waves, but I'm not sure.
Oh, but they're fog. That's crazy. Oh, I love it. I love it.
This has a new name now, and I'm
fog
going to
on the
type
ground.
it here just to make it clear.
Waves.
These are called fluxus clouds now.
Oh, that's right. They did just do that. Yeah. Oh, that is amazing. Where did you see those? Was that in Las Cruces? That's so cool.
I've got a lot of very cool pictures.
Wow!
Where
Where
you
you kept it?
You
You're
hurting
hurting
me.
me.
You're making
You're
me
making me
quiet.
quiet.
Oh, I'm not gonna say. Yeesh, Bria. Embarrassing me. I don't know. Well,
For you. Here's another one for you.
Mamatas. Mamatas are really, really cool, you guys. They're formed from incredible amounts of cold air, cold turbulent air rushing over the atmosphere and basically making little pockets, little bubbles. And so you'll see these kind of...
they do look like bubbles.
They do look like bubbles. You'll see them right after really bad weather has happened. You can go out and they'll just be like kind of beyond the anvil, like in the cloud base. And if they happen at sunset, they get really illuminated because of the way that light bends. They'll start to look really pink or really, really
I
blue.
think
Look
like
like
rain
rain
splashing
splashing
against
against
water.
water. They look
Yeah, you'll see these a lot.
cotton candy.
Like
Yeah,
I
they
get
kind
it.
of do. They kind of look like cotton candy.
They'll be like Gladys and those are cool. I don't know. Looks like they're like a flute. It looks yeah, a flute.
They almost look like rotor clouds, but I can't I can't
See,
see
they're
it.
fluctuous as well.
Uh-huh.
And for the young folks who are watching today,
No, this is called the whistles.
if you look up in the sky instead of down at your phones and your games, look up sky once in a while, you'll see things like this.
Mm-hmm.
There's always something interesting up there.
That was cool. I can't believe how many big clouds there are. What clouds only form during the sunset?
They actually don't only form during sunset. That just might be when you guys are out and you see them. Like times like this, like in the summer specifically, you don't see them as often at night in the desert where we are because of all the sinking air. Clouds need rising air in order to condensate and actually form. And here where we're at, it's just the way the upper level air flow patterns work. We're just more prone to having subsident air. We're more prone to having dry air. So in some respects, yeah, you are right. We'll see them more often in, kind of the late afternoon into the sunset. And that's because at that point, have you ever heard the term hot air rises, cold air sinks?
Yes, hotter does rise.
Right. And so there's a real fancy term for all this. It's called latent heat. And as hot air rises and latent heat becomes a thing, condensation can happen. And that is more likely to happen in the afternoon because the ground is so much warmer and we're getting it's a basic thermodynamic thing where that air goes up.
It's about I don't know. It's why does the weather ever change?
What did you say? I couldn't hear very well.
Does space's weather ever change?
Does space's weather ever change?
Yeah, like does it get clouds or colder? I meant
Outer space? So, did you guys know that there's actually a space weather forecasting office?
That's a thing.
That's a thing. So it's really, really cool. So space doesn't have clouds, right? Because there's no oxygen out there. So it's just it's a big vacuum. But you know what does happen in space? Solar flares. And solar flares can cause disruptions across cell phone networks, across power grids. And so that's what the Space Weather Forecasting Office does is it monitors that sort of, oh gosh, you have another test for me, I see. But the Space Weather Office monitors that sort of stuff and ends up, they forecast for power companies and for communications offices to let them know if these sorts of things are going to happen. Okay, Mike, I think I'm ready. I'm scared.
What is it?
He has a test for me.
You tell me what these are.
I gotta get oh man, I did the tweet on this and now suddenly I cannot remember what they're sundogs. Yeah, sundogs. Yeah. Oh, I love it. They're basically rainbows just kind of like stuck up in the sky. You see them most often at sunrise and you see them most often during cold weather. So in the winter, if you're ever up for any reason around like after sunrise, that's when you're most likely to see these. And they're so beautiful.
This actually happened at sunset.
Did they really? What time of year though?
October.
Okay, cool.
I have a question.
Follow me on Twitter here to see these pictures.
I'm definitely going to follow you on Twitter. I love all these so much.
Why is it so cold in space? Because it's hotter, right?
So check this out. This is really cool, right? So we have kind of like a thermal protective bubble over the Earth. We'll just kind of look at it that way. It gets up to a certain point, and we get to the stratosphere. At that point, temperature actually increases. And then you get into like the mesosphere and the ionosphere. We have all these different spheres, right? At some point, we get to space. Well, when we get to space, there's nothing there. It is a vacuum. So there's no water vapor. For example, water vapor can make everything very, very warm. It has a very high specific heat, which is a very fancy way of saying that it takes a lot of energy in order to heat water up or to cool water down. Well, there's none of that in space, right? And so there's no atmosphere. An atmosphere is what makes an area habitable, what makes it warm, and what protects us from the harshness of space. So there's no air up there. There's basically nothing. So it's just frigidly cold.
What is our atmosphere made of?
An atmosphere, say the last word again.
How's it made of?
The atmosphere is made of gases and water vapor. So we like to think that the atmosphere is primarily oxygen because as humans, that's what we love to breathe, but it's actually mostly nitrogen. So it's nitrogen and oxygen, and then there's some argon, there's some other trace gases mixed in, and then on top of that, there's water vapor.
Okay, we're running out of time. So, if you guys have your passport, if you got the passport, if you didn't, go ahead and download the passport. And the word you're going to mark there for this session is tracking. I'm going to put that in.
Mike, I'm sorry, I accidentally muted you. I'm sorry.
So the word for today for the passport is tracking. So if you have a passport, please go ahead and put that word in there and send it back to us. And if you don't have a passport, you can go on to the Explora site and you will see them there. And you can download one and print it out. And
What is the word again?
the word is tracking. I put it in the chat room as well.
Okay.
Well, they just vanished. They were going to get their passport. So at this point, I'll remind folks that we got a whole series of things about weather. And so go check it out. It's under Nature and Weather on the Science and Community part. There's also Science Destinations where you could even see Doppler Dave Spielman, one of our local weather forecasters down in El Paso, actually takes you through a day in the life of a weather forecaster. So he actually shows you what he does at the television studio. And Dave Dubois talks to you about climate, and various of the National Weather Service people have posted things up there for you. Monica Cortez down in El Paso again, she actually has a way for even the young folks like you to call her and take pictures and send them to her, and she'll actually show them on the broadcast. And in fact, just so you know what kinds of things that she looks for, I'm going to see if I can bring it up quickly here. One of my pictures actually got put on there, and I'm going to bring it up for you now. And let me do that. This particular picture got posted on the news broadcast. She actually showed it on the news broadcast. And this is a dust storm going through Las Cruces, New Mexico. We call that a haboob, H-A-B-O-O-B. That's the technical term for it. And yes, it sounds funny, and we get lots of laughter when we do that. But that is the technical term for one of these.
Can those be dangerous like tornadoes?
What's that? Can they be dangerous? Yes. And one that big can actually not really, it's not dangerous in that it hurts you by the wind so much as there's so much dust in the air, it can hurt your lungs. So you really should try to avoid those if possible. And also, if you're driving, do not drive through a dust storm. Pull aside, stay alive. Dust storms are much worse than fog, and I'm talking to the parents out there who drive. Pull over, stop your car, take the foot off the brake so your lights don't attract other cars, and wait it out. It's really dangerous to drive through something like this. So anyway, I think we can finish it up here. We're coming up on 6 o'clock. If you guys have more questions, I'm going to actually type my email into the chat room. Okay, and you can either catch it now or catch it in the recording later. We record all these and we post them later. If you want to ask questions about weather, you can send them to me and I will distribute it out to people like Blair and Dave Dubois, our climatologist, and some of the local weather forecasters at the TV stations. So I welcome those kind of emails. I will be watching for them and I will send them out to the other folks and they'll answer your questions there. All right, and at this point, I think we'll go ahead and wrap it up. Trish, you are before the recording. Go ahead. Blair, you wanted to say something at the end?
No, I just wanted to say thank you to you guys. You had great questions, and it was really fun to get to talk to you.